introduce you to Vas. So he'll be talking about Globus, so simplifying research data management. Globus is a software as service for research data management. Vas is the director of products at the Computation Institute, a joint initiative at the University of Chicago and Argonne National Lab, and is the chief customer officer for Globus. In this capacity, Vas works with the research computing community to promote and deliver the use of Globus services for research data management. He's also a lecturer in the master's program in computer science, where he teaches courses on cloud computing and product management. And with that, we will hand it over to Vas.
Great, thank you. Thanks, Leah, for the kind words, and thanks everyone for taking the time this afternoon. So as Leah said, I'm with the University of Chicago. My primary role on the Globus team is working with our customers on getting Globus out to the research community. And Globus is a service that's developed and operated by the University of Chicago, primarily for use by other researchers around the world. We also do have some commercial customers that use the service, but our primary mission is to serve the needs of the research community. So in a nutshell, this is sort of our elevator pitch, if you will. Globus is about big data transfer, sharing, data publication, and discovery. And two key points are that we do this all off existing storage systems, so whatever storage you have in place, Globus sort of adds value to that. And it is delivered as software as a service. This is not something that you deploy on campus. This is a hosted service that we operate for the community. And just some motivation as to how we got here. I saw some names on the attendee list that are probably familiar with Globus, so sort of bear with me. For those that are sort of new, I think this may help you frame what we do a little bit better. So this is the world of research data management that we saw a few years ago, walking around some of the labs here on the U Chicago campus. I was always particularly interested by this numbering scheme that we saw in one of the labs. I was wondering if that's sort of their high-tech index, and wondered what happens when the spreadsheet that tracks all those disks and all the contents goes away, right? So the question we asked ourselves is, how do you move and share and discover and reproduce data when this is what the state of the world looks like? So we set out to address a number of scenarios, and many of them center around this notion of bridging, right? So bridging to campus high-performance computing infrastructure is one thing that's very common in our space, and one thing that we address routinely. So you have a data set you want to move from the lab to your campus cluster, do some analysis, and move it back to various places. Bridging, sort of scaling out from there, or scaling up to larger, capability class machines, like some of the supercomputers at national facilities or some of the DOE labs. Bridging to instruments, right? So we're familiar with the explosion of data from things like next-gen sequencers, and on the left here is one of the light source beam lines at the advanced photon source at Argonne. So there's many such instruments that are generating, in many orders of magnitude more data than they were just a few years ago. So how do you, move this data to where it needs to go for analysis, for archival, etc. Bridging to collaborators, right? So the research is going to be collaborative, and it traditionally has been a very difficult thing to share data when you start crossing institutional boundaries. And this working group, I believe, is tasked with looking at some of the ways in which that can be made more efficient, simpler. And so we have some thoughts on that, and have built some capabilities in Globus to make that what we think is fairly trivial, both to share with external collaborators, but also to put data outside of the institution on things like public cloud services and some private cloud stores as well. And then, as is common in any academic research endeavor, there is a publication requirement where you may be required, or you desire to share data more broadly with the community or with the public. So how do you facilitate that whole process? So that's kind of one of the services that we added in recent years in Globus. So just walking through the core functions of the service, the thing we started out with about 7 years ago was just file transfer, right? Something that to us seemed fairly simple at the time, but as we discovered was quite a challenge for a lot of folks, especially when the data scales were large, because of things like networks being flaky, storage systems doing their thing, different credentials being required to access different systems, and so on. So we built essentially a managed file transfer service as the first thing. And the way this works is a researcher comes along, they have their data sitting on an instrument or on a lab server somewhere, and they want to move it to another system for whatever purpose. So all they do is they fire off a request to Globus and say, move this data from A to B. At that point, the service takes over, and Globus just works to transfer that data as quickly as possible and primarily reliably, right? That's the core sort of value, if you will, of the service is this notion of reliability, such that we ensure the data just, it moves. So it just gets done without the researcher having to worry about, what it's doing, something's failed, where did things leave off, and so on, right? So some of these transfers, depending on, what endpoints or what systems live on either end, could take, many days. In some cases, we've had one transfer that ran multiple months, from a remote part of the world, moving data over a very slow, very low bandwidth network. So, how do you ensure that those kinds of transfers complete, and they complete reliably and securely and so on, right? So that's really at the heart of the service. And we'll reach out to the user if we need to, if we need their intervention for something. But typically, the service just takes care of things. The next thing we introduced probably about 4.5 years ago now is this sharing capability. So being able to grant access to your data to other collaborators who may not necessarily have local accounts or access on your systems, right? So what the researcher would do is select the files they want to share, decide or tell Globus who they want to share them with, and then set the appropriate permissions. Can they read or can they write that data? And then Globus will control access without requiring you to move that data to some cloud service or to some other special purpose store just for the purposes of sharing. And there's no need for your collaborators to create temporary accounts and have your IT and admin staff dealing with that complexity over time. They can just log into Globus and access that data directly from that system. They can move it to their own local machine or to some other system that they have access to and do whatever they need to do as part of their research workflows. And then sort of on the tail end, as I mentioned, is usually in many cases a mandate to make some data more publicly available, or the researchers want to share with their extended community or others beyond their working group. So there's the ability to collect data and sort of assemble a data set for publication from multiple systems, attach some metadata to it using things like standard schemas like the Dublin core schemas, and optionally put it through some kind of curation process where the data is reviewed, and then once it's published, you can actually have others, come along, use the Globus service to search and find that data, and go to, persistent locations and download it and use it further. So it in a sense, we try and cover some of the key tests throughout the research life cycle. We haven't covered everything, obviously. It's a very complex space, and we haven't covered by any means most of the scenarios, but these are sort of the things that are fairly common in the environments that we've been working with researchers across pretty much any discipline nowadays. And a couple of key points on Globus overall. So for the most part, it's a thing that researchers access via a browser. There are other interfaces, but that's the primary interface. And I say we can use any storage system as long as as long as we support it, as long as we have a connector for it, and that largely means most POSIX file systems and a whole bunch of other custom storage systems like object stores and archives are all available, and you can access it using an existing identity. I'll talk more to that when I do a demonstration in just a couple of minutes here. So you might ask, well, why use it? Okay, these sound like interesting functions. The things we focused on are along dimensions, right? The one is simplicity. So we do present this consistent user interface across different storage systems. So you could be looking on the one hand at an Amazon S3 bucket. On the other end, you could be looking at a tape storage, tape archive on your campus, and they look just like your normal file browser. You can just move files between them. And easy access to collaborators, right? I'll show you what that looks like in just a second on the live system. The second dimension we focus on is reliability and performance. So the protocol we use under the covers to move the data is Grid FTP. It's a standard, tried and trusted protocol. It performs exceptionally well, especially on the sort of the higher speed networks that we have in the research world. And this reliability notion, we talk about it as fire and forget. As a researcher, I fire off a request to Globus, and then I can forget about it, and I'll just be notified when it's done. And then from the perspective of the sort of the administrators or those that are managing the storage systems connected to Globus, we really focused on operational efficiency. So we do have, as I said, a process model. You install a small client, if you will, on your storage system, and then it's available via the Globus service. But we've also provided command line tools and REST API so that the service can be accessed from other applications and from other environments as part of existing workflows. But sort of underlying all of this, the value that people really tell us, talk more about, is this access to the large and growing community. We now have, I think, upwards of 50,000 registered endpoints on the service. There's about 10 or 12,000 that are active in any given year. So it's a growing community, and there's lots of value to be had from that. So I'm going to switch out of slides there, and Leah, I don't know how you want to, or Carl, I don't know how you want to handle questions. If you want to just keep going and save questions for the end, or I can take questions as we go along here. I don't mind either way. Okay, so I will just walk through the transfer and sharing capabilities and maybe some of the admin things. Just want to stay on time here, what, 14 minutes or so. Okay, so logging into Globus, as I said, it's accessible via many existing identities. We federate with the in-common federation, so we have all the identity providers from the in-common federation, as well as many providers from other countries. We're in the process of integrating with the EduGain Federation. So this list, which is now, I think, 350 odd providers, will grow to about 1,500 or so. We also support Google and Orchid down here. But I'm just going to use my University of Chicago ID. And what this does is basically just like any other federated identity system, it's going to direct me to that identity provider. In this case, this is my campus login page. So I will log in with my campus credentials, and then I'll get redirected back to Globus. So I've authenticated, and the primary interface is the traditional sort of left and right pane file transfer screen that you've seen on many tools, I'm sure. So I mentioned this concept of an endpoint. So when I say endpoint, I'm referring to any storage system that has the Globus Connect client. That's the thing where that's what you install on the system to expose it, if you will, via the Globus service. So we call that Globus Connect. So we, given the large number of endpoints, we've got a pretty robust search capability to find the ones you're looking for. We also track recently used, and you can bookmark endpoints and paths and so on. So I'm going to click here on this endpoint, which is our Midway cluster. This is just a big, standard HPC cluster on campus here. And you'll see when I do that, it drops me straight into my home directory on that system. That's because wherever possible, Globus will do single sign-on. So in this instance, I just logged in with my campus identity to Globus. So therefore, it has that credential, and it presents that to this cluster, and it's recognized because we do have single sign-on on all our campus resources. So I just get dropped straight in. So let's say I've run some experiments. So I've got I don't know, some data here. I can just go find something to move. So let's say I have this 100 meg file, nothing too big, and I want to move that to another resource outside of the campus. So let's say I want to go to Exceed, and I want to access, let's do Gordon, because I used that earlier. So Gordon is a supercomputer out at San Diego Supercomputing Center. So I'm going to move files here from Chicago to Gordon. So now when I try and access Gordon, it says please authenticate, right? Because Gordon does not recognize my University of Chicago credential. It needs, in this case, Exceed credentials, because Gordon, in this case, is managed by the Exceed project. So I do have an Exceed account, so I'm going to go ahead and log in with that. And shortly, I should be redirected back if Exceed is cooperating. And I'll get dropped into Gordon. So actually, I'll move these 3 files. So I'll select those, and firing off a transfer is as simple as clicking that button, right? So Globus says transfer request submitted successfully. So it doesn't mean the transfer is completed, but Globus has the request, and it's going to work on it and try and get those files over there, as fast as possible, but maintaining the reliability, right? There are options I can set on the transfer down here. I can choose to encrypt it. That's a requirement for certain types of data, obviously. It's not a requirement for either of these systems, but as an administrator, you can force that to be an option on your system so that users, have to encrypt all their transfers. And there are other options that I can choose to sync or delete and so on. It looks like this one's already finished. It wasn't very big, but I could go and look at it. While it's running here, I can go and get and see what's going on and how fast it's moving and so on. But that's all that transfer is about. It's we've tried to make it as simple as possible. Again, you can navigate these tens of thousands of endpoints, and they all look fairly similar, right? I could just as easily go to I have an S3 bucket on Amazon where we store some shared documents, right? That looks just the same, right? So that's another Globus endpoint. It just happens to be an S3 bucket. So this consistent user interface is important. The reliability is important, so on. The other thing I mentioned is sharing. So let me just go up a level here. So let's say I wanted to share some data here about my results from doing some runs on the Zeiss light sheet microscope. Let's say I want to share that with the big data hub group, right? So I'm going to do the big data South hub share. So what I'm doing here is I'm creating what's called a shared endpoint. So if I wanted to share with all of you folks on the line, I had you set up in a group somewhere, or I had you individually identified, however, but none of you have access to my campus cluster. All I would need to know is either put you in a group with your identities in Globus, or I can just invite you via email. In this case, I'm actually going to use a temporary user that I use for demonstration purposes. So I can find a user to share with, or if I know them, I can just add them straight in, grant them permission. So now Globus, you'll see up here, it's added this permission. It's a read permission for this demo doc user. So this user will now get an email saying, Vas has shared this data with you. Click on this link to access the data. So it's very akin to Dropbox or other, cloud sharing services like that. So I'll go in and switch to another browser here, and I will log in as a demo doc user. And let's say this user could have an ID from one of these existing identity providers that we've federated with. They can always use what's called a Globus ID. So it's a Globus username and password. You can go create one. And so I will just log in as that demo user. And when that user goes to, what do we call it, big data, see how many of those, not too many, right? So there's that endpoint, that sort of virtual endpoint, if you will, that I created. And they're looking at the data. You notice they can't navigate up or out in that file system. All they can see is the data that I shared with them in this folder here. right? So at this point, they can pull that down to their systems and do what they want with it. So fairly straightforward. Hopefully, you agree. No need to, special permissions, get an account on the system, jump through all those hoops, or move data to some special place to share. Just directly share it from the system in place. And a number of administrative capabilities. We have a console that gives you a real-time view into data transfers. Some big transfers going on right now. If I mouse over some of these, the bands will change. So this one's a pretty big one. This is NCSA Blue Water supercomputer. So as an administrator, you have this view, so you can see who's moving what. You can see which transfers might be experiencing problems. Orange means that Globus is actually retrying, so that's part of the value proposition that we will try and work through transient errors. So that'll always show up, and that's actually a good sign. It means that Globus is doing what it was designed to do. So I'm gonna pause there on the demo. Just want to stay on track. Switch back to show you a couple more slides. I'm just going to talk through how you actually deploy Globus, right? So I mentioned Globus Connect. So that's a piece of client software that you install on your storage system to turn it into a Globus endpoint. There's a personal version, so it allows you to create an endpoint on your laptop or sort of your desktop, whatever single user machine. It doesn't need any special access to install and configure. There is a Globus Connect server version, which most folks will install on their campus cluster, lab server, what have you. We support many different types of Linux distributions. And I mentioned we support lots of different file system types. So we have part of the standard package, any POSIX compliant file system is supported, but we also have what we call premium storage connectors. These are the ones that we currently have out there in some form. And available and supported, and we're working on connectors for others, typically a lot of the object cloud stores that people are using more and more. I'm just going to skip through some of these. So the other thing that you can do with Globus is it's actually exposed as a platform service, so you can actually use the Globus capabilities when you're building your own applications, science gateways, data management portals, etc. So you have access to a full set of APIs for these transfer and sharing and publication functions. You also have access to all that federated identity and single sign-on capabilities, so you can actually use the Globus service as your authentication system, so you don't have to build username and password and all the cruft that goes with managing users and credentials into your system. Some examples of people that have done this, the Research Data Archive at NCAR uses Globus to serve the data up to their 40-odd thousand users around the world. Stanger does the same thing for genomics imputation analysis. There are a number of different examples. We do have samples and open source code on our GitHub repo on how you can use the platform if that's of interest to folks. I do want to, before I close here, just thank our sponsors. So Globus is funded by, the development at least is funded by many of the national, the federal agencies, as well as the labs and some private foundations. I mentioned some of these numbers, so we do have, service is growing nicely. We've got over 50,000 users now, a bunch of endpoints. And we do have a sort of a two-pronged model. So we have a free service that nonprofit researchers can use, but we're trying to become self-sustaining. So we've introduced subscriptions, paid subscriptions a couple of years ago, and we do have, I want to thank the many, this is a subset of the folks that actually currently pay to use Globus and they take advantage of the subscriptions. And that actually helps fund our operations because, we can't fund those things through federal grants. So through these subscriptions, you get access to, beyond the transfer, which is free, the sharing function that I showed you, some of the management capabilities, and a number of other features that I didn't get a chance to go through here. Those are all supported by subscription. So that's all I have for now. Sorry, I think I might have run a little over time. I apologize.
A little bit, but we're still okay. So thank you, Vas. Does anyone have questions? So we'll open the floor to questions. And you may want to unmute your mic if you have your mic mute or have had your mic muted before you start talking. Is there someone there that was about to ask a question? No? Okay.
Can you hear me now?
Yeah, we can hear you now. That's great.
Okay.
Go ahead.
Sorry, my apologies. So this is Stan Ahoff. I have a question about, so you mentioned the fact that you were using kind of an optimized file transfer methods. Can you speak a little bit more to that and maybe kind of talk about the bandwidth you get on a good connection and on a bad connection?
Certainly, yes. So we have two protocols. The primary one is grid FTP. So that's if you're not familiar with it, it's an open standard. It's based on FTP, but it actually gets around all the constraints that traditional FTP has. So think of it as a parallel form of FTP, and we get parallelism through two dimensions. One is you have the option to open up multiple concurrent sessions between the two endpoints, so you can spread your files, individual files across all those sessions. And then within each concurrent session, the protocol allows you to create multiple parallel threads, and so the file gets chunked up across those threads, and so you get these two levels of parallelism, and that's what gives you the performance. And it also does some other things to overcome some of the shortcomings of TCP networks and pipelining commands and things like that. So it does get performance on the order of 20 to 100 times that of SCP over similar links. The performance tests that people like ESNet have done, if you're not familiar with ESNet, they run the networks for the DOE. So they did a lot of independent testing, and they continue to work with us. So they've managed to get disk-to-disk throughput of close to 8 gigs on a 10 gig link. And then actually that was, I think, limited by the I/O bandwidth on the file system. So, grid FTP, the underlying protocol, we've demonstrated that it can essentially saturate a 100 gig link. We've done those tests. In fact, last year at Supercomputing, we demonstrated 95 gigs disk to disk across the wide area network, which was, I think, the two endpoints were a couple thousand miles apart. So, so yeah, the protocol is pretty robust, but a lot of it does depend, obviously, on what system you have on either end of it.
Great, thanks.